So now I want to take a look at the Angry Birds puzzles that you saw for today's tickets and just bring out some of the highlights from there. According to this, in part 6, 1, 2, 3, 4, 5, 6, please. That's number 7. That's number 6. Now it says 5. Nice. In number 6, we're supposed to use a repeat loop to get the bird from here to there. I might be able to zoom in just a smidge here. Get the bird from here to there, but use a repeat loop. And remember, I complained about Lightbot not doing repeats the way programmers do it, because we were using that recursive technique where a procedure calls itself. Not very likely. More likely to do something like this, where at the top of the code you put a repeat command or something similar. Every language does it a little bit different. Put a repeat command. How many times do you want to repeat it? 1, 2, 3, 4, 5. That's perfect. Or you can change it. And then what do you want to do over and over and over again? But a limit. There's always a limit when you run loops. Remember, here we can show the code. One of the things I'd like you to recognize here in showing the code is not so much this complicated syntax and what that means. We'll deal with that in October sometime. But more importantly, notice the indentation. This is the loop. It starts here and it ends here. This is written in JavaScript. That's a curly bracket language is what we call it, because there's a lot of these curly brackets in them. C# is a curly bracket language. Lots of curly bracket languages out there, all very similar yet subtly different. This is JavaScript. Again, remember, move forward is a procedure that somebody's written to make that bird bounce and shift all those pixels over to the next position. Okay. And then here's the 5 that I chose. But why does it start counting at 0? That seems weird. Computers start counting at 0. So if I'm counting students, he's student number 0, student number 1, student number 2, student number 3. That won't come back to haunt you until October either. Nothing exciting in 7. So let's go to 8. Help me banish the bad piggy. Try using more than one repeat, using the fewest number of blocks. That's not a goal in real programming. In real programming, we're looking for maintainable code. Okay. So fewest number of blocks, I'm going to repeat to get to here, then I'm going to turn, and I'm going to repeat to get to there. So this is 1, 2, 3, 4 steps. Turn, I have to have my situational awareness, going straight, turn left. And then another loop. 5 times this time, because I think that one's 5 up. So loops can be stacked, so you do this, and when you're done, then you do this. Or we can have a loop that's got a loop inside it. All kinds of ways to put these different tools, these repetition processes together. You can kind of see it going through this 4 times, see it flashing. 4, and it's done, leaves the loop. How does the loop know when it's gone through the process 4 times? That's part of the command. It's built into the language. When you tell it do it 4 times, the language itself keeps track of how many times it's done it, and it quits. We look at the code here. There's another one of those 4 loops, they're called. Doesn't look like I can get that scrolled very well. Can't get it to scroll at all, but there's another 4 loop underneath there. Can't move this guy. So there's another 4 loop underneath. You'll learn all about that indentation and all about this stuff as we go. In the real world, under the loops defined using a relationship. Okay. So I'm going to go to problem number 10 here. No, I don't want to see the video. And notice this says repeat until pig. That's kind of tough to do. Right. But if we look at the code that's generated by this, okay, sometimes we don't know how many times we're going to do this. How many students are in the class? Sometimes it's 24, sometimes it's 11, sometimes it's 10. We can say repeat until you're done, or repeat until you hit the last student, or repeat until the end of the file is very common. When I run this, what I really want to do is look at the code. Notice the condition here. It's called a condition. It's a true-false thing. Am I done? Am I done? Am I done? Have I done 5? Is it the end of file? Is some kind of a condition here. And here they've written another procedure that defines finished. What's finished? When the bird icon is sitting on top of the pig icon, they have the same location on the screen, then you're finished. That's what's going on behind the scenes there. It's not as simple as repeat until pig. Not quite that simple. Part 12, can you get me there in only 5 blocks? Well, again, normally you don't have a limitation, but why 5 blocks? Because that's the most elegant solution. What do I want him to do? Repeat until you hit the sunflower, again, until finished. But notice, when we look at the code here, the finished is a different definition, right? Before, not finished was pig. Now, not finished is sunflower. That's the nice thing about functions. We can give them the same name, make them do different things. What do we want to do here? We want to walk and turn left. Walk and turn left, walk and turn left, walk, turn left, and then right. Oh, okay. 5 blocks. The repeat block. I want to walk, forgot that part. Turn left, walk, turn right. Now I'm going through this. I'm not trying to solve it because most of you solved it without too much trouble, but what's the magic? What's magic about 5 here is it's the most elegant solution. There may be other ways to do this, but this is the best solution. That's why they said 5. But you don't get those kind of hints in the real programming world, and no, I don't think I want to watch Zombie go through all of that stuff. Let's see what else is interesting. Finally, okay, part 14. We finally get to ask questions. Here's an if statement. If there's a path to the left, then do something. Okay. Fortunately, my small screen here, I guess I could make that a little bigger. If there's a path to the left, then do something. What if there is no path to the left? Then don't do it. Right? So here's my zombie, and there's no path to the left. He takes a step, there's no path. Notice there's a loop on the outside that says, keep moving until you hit the sunflower. If there's a path to the left, turn left. Take it, basically, and go. If I accidentally said turn right, what would happen? Then he hits this little guy down here, which is his own little fun. What happens if I get eaten up? What does the program do? Remember last time, oops, I solved it, now I can't go back. Sometimes it's good to experiment. If there's a path to the left, go right. Oops. Now what happens? Takes the path to the left. Notice the little radar going on. Oh, there's a path to the left. Turn right. And then keep going, chomp. That was fun. But the nice thing about Angry Birds is if you don't use the approved solution, they say, try it again with this. Maybe this is your problem. So it's a nice little bonus. No, I don't want to try it again. 15, we talked about the zombies radar. When we say walk here, or move forward, that has its own definition. The zombie walks, plus the little radar thing shoots out. And it's amazing because if he's looking for a path to the left, then his radar shoots out to the left, and that's interesting. So even the definition of move forward changes because what am I looking for? I'm looking for a path to the left, then use the left radar. Interesting stuff. The video here, a lot of these last ones you flew right through them because they were very, very similar. But if you watch the video, I think it was the basketball player, I forget, it wasn't LeBron James, so I don't even know the guy's name, but he said after practice, before he let himself go home, he had to make 10 free throws in a row. Shooting a free throw is pretty much the same mechanics every single time, right? So why do I do it over and over and over again so that it's right over and over and over again? And when you need to do it again, you'll recognize it and you'll know how to deal with it. Same thing here. A lot of the solutions are very much the same. Part 18. Now we're going to make decisions with an if-else. All right. Now here's my sunflower and here's my zombie, but he's just turning left. Okay. If there's a path ahead, again, how do we define there's something ahead? Then walk. But if there's not, if you hit a dead end, in this case, turn left. Right. Then, oops, we missed a loop. Here's the loop. Put all of that, oh, come on, really? Inside the loop. So we go forward or we turn left. We go forward or we go turn left. In this puzzle, turning left gets me where I want to go. In the next one, things get a little more complicated because there's a right turn. And no, it's not any more complicated, it's just right turn, so that's boring. Must be this one I'm looking for. Okay. Now things are getting tricky because I do a right turn. Now I'm into right turn, left turn. And also notice how these Lego blocks are starting to put together. But again, notice it's nothing but sequential processing, repetition processing, and decisions. This is called a nested if. It's an if that's inside another if. Unit 5. Ways down the road. If there's a path ahead, then walk. If there is no path ahead, you've hit a wall. But now we have to figure out which way to turn. Can I turn to the right? Yes, then do it. No, there is nothing to the right, then go the other way. Okay. Great ways to learn some of this stuff. But notice the nesting. And again, if I show the code, notice all the curly bracket, now you know why they're called curly bracket languages. They're everywhere. And yes, they're required. Okay. If there's a path forward, then go forward. Else, ask another question. Should I go left? Should I go right? Or excuse me, should I go right? Should I go left? This shows you the logic. What it doesn't show you is all the complexity that's hiding inside. Is there a path to the right? How do I know that? Behind the scenes, there's something there. We're going to refer back to these starting in Unit 4 and talk about the lessons learned. May even refer back to them sooner than that. But Lesson 4, Unit 5, and 6 all refer to decisions and repetition, and I might have you go back and do a few of these just to refresh your memory. Question?
On the zombie one, I think it was puzzle 19, there was a do nothing. I did, and it
Was it do nothing command, you mean?
Yeah, like it didn't do nothing. There wasn't a do nothing command, but I left it blank. And it took me all the way to the end, but it didn't say that it was
Okay.
completed.
What did you want to do nothing for? Oh, you did this, right? Oh, I don't know why you would do nothing. If you walk ahead, if there's a path ahead, go ahead. Otherwise, I have to turn right in this one, right?
Yeah.
Okay, so here's my turn right. Where did you want to do nothing?
It was on, not this one, it was on.
This one's 19.
Yeah, number 19.
That's where I am.
Oh, you are, 19.
So maybe you had an extra one of these stuck in there someplace. Don't know. You can leave these blank.
That's what I did, is I left
All
it
right,
blank.
but if you do that, he just moves ahead. This is going to loop forever because he's never going to make the corner.
That's probably why it stopped. Is 'cause
That's-
I got into the sunflower.
With this zombie, that's another good point. With this zombie, when you hit a wall, notice it flashing? And it finally gave up. Okay. That's called an endless loop. It went forever, but this program was smart enough to say, you're not getting anywhere, I'm quitting. Okay. Zombies don't like to run into walls here, and you tell them to bump that wall harder. they start to choke. If there's a do nothing, we had that in one of the earlier examples here. Was it 14, the if statement kicked in, but this one might work. Yeah. If there's a path to the left, then do this. If there's not, skip it. That's a do nothing path. Right, those happen in the real world as well. These zombie Angry Bird puzzles are very good at demonstrating to you how loops work in real programs and how decisions are made. Sometimes you do this or this. You never do both. Other times you do this, and if the condition is false, you just skip it. You don't do it. A classic example there is if the user is female, ask for their maiden name. Well, if it's a male, as far as I know, males still haven't picked up that maiden name habit yet. Doesn't mean the female has a maiden name, but for males, we're not even going to ask. Females will at least ask. So that's a kind of a classic example. All right, enough Angry Birds stuff. Let me stop my recording, let it